Well, hello and welcome to this Climate Now live here on Euronews YouTube channel. Please send us your questions and we will try to answer them. So what is happening in the Arctic, Greenland and Antarctica? We hear that the ice caps are melting, but what's the reality at the poles? And what does it mean for the billions of people who live in towns and cities where the sea level may impact on their lives? Here to help us understand more are our guests. Please introduce yourselves.
Hello, I'm Dr. Ruth Mottram. I'm a climate scientist at the Danish Meteorological Institute.
Hello, I'm Levermann. I'm a climate physics professor at the Potsdam Institute for Climate Impact Research in Germany.
Hello, I'm Professor David Vaughan. I'm Director of Science at the British Antarctic Survey.
Thanks very much, everybody, for being with us. I want to start by talking about what's happening in the Arctic and bringing up a graphic which we were able to show on our program Climate Now on Euronews this month. This is data from the Copernicus Climate Change Service showing the sea ice anomaly for October 2020. This is fresh data, and that area there in red is an area where there's a lot less sea ice than there should be. Ruth, can you explain to us why is there no sea ice in the Arctic at the moment?
Well, it's been a very warm year in the Arctic, and it's been persistently warm for months and months, and that warms up the sea. It makes it much harder for sea ice to form when the freezing season comes back. But it's been a long-term problem. So year after year, we've seen very low sea ice levels in the Arctic. And that means that when sea ice does form, it tends to be quite thin, and then it can't survive the melt season. So it gets harder to refreeze again in the following year.
Does it really matter, though, that we haven't really got that much sea ice there in the Arctic? Because personally, I don't feel particularly affected by it. I report it, but is it changing things for us here?
So I think that it's important to say that it has a big impact on the ecology of the Arctic. So there's an impact on Arctic species. There are certainly knock-on impacts downstream. There's quite a lot of evidence that this in some way affects the climate in the sort of mid-latitudes where we live. And there's also lots of, it's a sign that there are very big changes happening in the planet. And so it's a sort of a very clear marker of the climate change that's ongoing at the moment.
Anders, what are your thoughts on this? The lack of sea ice in the Arctic, what are the real implications?
Well, of course, what Ruth says is very important, and the ecology, the local climate, if you like. Also, the Earth is getting warmer because there's less sea ice on the planet, because there's less sunlight reflected back into space. But the big question is coming up now is whether the lack of sea ice and this very strong warming that we see in the Arctic is really affecting the planetary wave system around the planet. We have this circular wave of winds around the Arctic, which is influencing or is kind of protecting us from the Arctic, from the cold air masses of the Arctic in Europe, in the US, in Canada, and also in Asia. And we every now and then we see that this wind belt is meandering, it's starting to meander, and when that happens, things change dramatically quickly around the planet in different regions, and that could really affect us in mid-latitudes here.
Could that end up making it colder in Europe?
Well, these are really weather phenomena, right? And we don't understand the physics completely yet of how the melting of the Arctic sea ice is affecting this circulation pattern, the change in the circulation pattern. We don't have a complete evidence in the observational data yet, but it's a possibility. And whenever you have this meandering of the jet stream, you suddenly have bursts of cold air coming far to the south, and that can lead to heavy snowfall or just a cold spell. And if it's going to the north, then you suddenly have a heat wave over Greenland, which is not supposed to be there because too much tropical air is coming too far to the north. So these kind of sudden and bursts of different weather systems are something that is likely to affect us around the planet.
I think we'll come back to the Arctic, but I want to bring in David here, who's fiddling around with his phone at the moment, but I'm sure he can hear us more or less. What's happening in Antarctica at the moment, and is it really different to what's happening in the Arctic? I'm not sure whether he can
the
hear
Antarctic
us.
has persistently been different from the respective sea ice for many years, with a decrease, an increase in the extent of Antarctic sea ice going on. But we know why that is, and it's really because the same amount or similar amount of sea ice is there, but the increasing winds that are driven by climate change actually spread that ice out further into the Southern Ocean. And here the geography difference between the Arctic, an ocean surrounded by a set of continents, to the Antarctic, which is a continent surrounded by open ocean, allows that sea ice to spread further and to give a very different pattern of change in the Antarctic. However, having said that, in recent years, we have seen loss of sea ice around the Antarctic, which is probably just the temperature increase really overtaking all other changes. So in the future, we expect to see similar changes in the Antarctic as have already been seen in the Arctic. A reduction.
So that's interesting. It's kind of basically there's a change that's kind of spreading the sea ice out, because I saw that the sea ice extent was increasing in some areas. Is it sort of thinner than it was?
It could be thinner than it was. It certainly may be. In terms of sea ice, we classify sea ice in terms of the number of the percentage of the sea area that it covers. So we might have sea ice, say 5/10 of the surface coverage, or we might have it at 10/10, which would be complete coverage. What we suspect is that we have lower levels of coverage around the Antarctic. Now this sea ice is blown apart, if you like, by increased winds and spread further afield. Doesn't necessarily mean that we have less or indeed more sea ice in volume terms around the Antarctic.
Okay, let's talk about what's happening there in terms of the glaciers. And I know that Anders has been putting together some quite extraordinary projections about what will happen as we move forward with the temperature changes, which we already have. I mean, you know, we can say that we're in a over 1 degree of warming world now. Can you talk to us a bit about what the research that you did recently and the projections that you've been making, because some of the numbers are quite interesting.
Yes, I mean, it has, you know, both Ruth and David mentioned this, but there are strong differences between the Arctic and Antarctica, and I don't know whether that became clear because of the quality of the transmission. The Arctic is an ocean, right, surrounded by land, as Dave said, and Antarctica is an island surrounded by an ocean, so it's fundamentally different. Which means that if the Arctic is melting as it does dramatically, sea level is not increasing, not rising. While if Antarctica, the land ice on Antarctica loses ice, then sea level is rising. And there's a lot of ice on Antarctica. It has the potential to elevate sea level up to 55 meters globally if all of it would get into the ocean. And that won't happen overnight. It won't happen unless we really heat up the planet very dramatically. But what one can do in a computer model is one can ask how much ice survives at what temperature level. And if we do this, and that's what we've done recently with our model, and you know, there are other models on the planet which would do the same, could do the same thing and would find similar numbers, we hope, then we find that there's a sensitivity of the ice sheet that is dramatically increasing if you further increase the temperature of the planet. So if you, up to 2 degrees of global warming, we are currently at 1 degree Celsius of global warming, up to 2 degrees of global warming, you have a relatively mild response of the Antarctic ice sheet. There is sea level contribution, but the sensitivity is relatively small. If you further increase, if you go beyond 2 degrees, then the sensitivity of the Antarctic ice sheet increases, meaning that you lose more ice for every degree of additional warming. And if you pass the 6 degrees, which we can't do in this century, but what we could do in the next century, then the sensitivity increases even more strongly. And then for every degree of warming, you get 10 meters of global sea level contribution only from Antarctica. That's very important to emphasize. That's on a long term, on a multi-millennial time scale. So that won't happen overnight, but it's something to keep in mind if we think about the cultural heritage of our civilization and the cultural heritage near our coastlines.
No, you're absolutely right. And I remember you talking to me about cultural heritage and being quite striking to sort of think about European cities that have celebrated their 500th birthday or something, and will they be able to celebrate their future, 1000th year birthday? I want to take in some questions that we've had. And we're open to all kinds of questions, as long as we're sensible and we can understand what it is you're asking. I don't mind what it is you ask, if you see what I mean. Question from Chanda Bozio. Climate change in history. What is the scientific proof that the cause is human-made in modern days? Thanks for your response. Basically asking to what proof we have that it's human activity. Ice has come and gone. Isn't that just a normal thing? Go on, Ruth.
It's amazing in 2020 we still get this question, because the physics of climate change has been really well understood since the 1880s, really, and the way the climate is controlled in part by the greenhouse gas concentration in the atmosphere. And the first person was famously Svante Arrhenius, who was a Swedish physicist in the 1880s, who made a calculation based on burning of coal and how much global temperature would rise. The first person to actually show that the climate was warming and to attribute it to climate change, to burning of fossil fuels, was Guy Callender in the 1920s. Eunice Foote, who was an American housewife, she also showed this. Tyndall. So it's very well established physics that the amount of greenhouse gases in the atmosphere controls the global average temperature, and that has a cascade of effects. People are often confused because we can see
it has happened, right? It has happened over the last 300,000 years or so. So isn't it just one of those things happening again? And the question always comes around that.
Yes, so the point about the sort of ice ages has been reasonably well worked out by Milutin Milankovic, who was a Serbian physicist in the 20th century, early 20th century, showing that basically changes in our orbit around the sun can really affect the amount of solar radiation that's coming in, and that can explain this kind of pacing of ice ages. If we add together all of those things, we can actually really begin to see that the only way we can explain the observed warming already is by looking at our increase in greenhouse gases since the industrial period.
You're obviously gathering some interest here, because another question I just got here was saying from somebody called Linda, saying that aren't there volcanoes under the Arctic melting the glaciers? Isn't that what's happening? Is that the case? Are there volcanoes underneath there? Is that our process? I've never heard of that.
There are some volcanoes in Iceland, and there are some places in Greenland where we believe there is slightly warmer bedrock that is helping the glaciers to slide a little bit faster in one or two places, but it's not a very significant process in Greenland. There are some volcanoes in Antarctica, but the same thing is actually true. You can look at the sort of total amount of gases that these volcanoes output, and it's very small compared to the sort of man-made emissions.
Yeah, okay, so that's super interesting. I wasn't aware of that. So yeah, so a very small contribution. There is one, a very small one. And another question we got, which was on Instagram. Thanks for your questions coming in from at Jogsandrix, saying, what year is it predicted that these ice caps will fully melt, particularly the Arctic? Let's go back to the Arctic. Do we have a kind of a year in mind when the Arctic will be ice free in the summertime? It's often predicted it might happen relatively soon. Is there a time that people talk about now?
So I think it's important we have to distinguish, as Anders was also pointing out, that we have, when people talk about the Arctic ice caps, sometimes they mean different things. So sometimes they mean the Arctic sea ice, which is floating and melts and refreezes every year. And the sort of current prognosis is around about the middle of the century. Around about 2050, we expect to start getting more regular periods where there's very little sea ice in the summer. And that doesn't mean there's no sea ice. There's just small amounts, and it's fragmented, and it's maybe not all in one place. And then sort of getting towards 2150, so maybe 100 years after that, depending on emission scenarios, you might see that there may be no winter sea ice, but that's a long time in the future. And when we look at things like the Greenland ice sheet, which is enormous, not as big as Antarctica, but it contains about 7 meters of sea level rise, it's also on hundreds of years to thousands of years, and under a high emissions scenario. So if we burn everything, we might expect to lose Greenland within about 1,000 years, maybe longer, that kind of timescale.
It might be a time for us to bring up some of the photos that we have actually from one of our reporters from Euronews, Danish, who went to Greenland to help you understand this. This is one of the photos that we took for our ocean series. That in the distance right there, that is an iceberg. So that is not sea ice. That is contributing to sea level rise, what we have there in that photo. Can somebody just explain to me why this is happening and appears to be accelerating? Because that is the understanding that's in the mind of the general public. But surely it still snows in Greenland. Why is there a problem?
It still snows in Greenland, and in fact, we expect it to snow more in Greenland in the future because of warmer atmosphere. We typically get more precipitation, more snow, more rain. But what's more importantly is what's happening is that in the summertime, it's also melting a lot more in Greenland. And so every year we see these years where year after year, Greenland loses more ice than it gains. And so it can only gain ice by snowfall. It can lose ice two ways, either by surface melt, which then runs off into the ocean, or by the loss of ice by carving of icebergs, as you just showed a very beautiful picture of. And that process of carving of icebergs has also accelerated in the last sort of 20, 30 years. So over the last 20 years, we've really seen an increase in the amount of ice that's being lost by both these processes, both melt and the loss of ice by carving of icebergs.
And that is really a temperature thing. There aren't other factors particularly involved.
No, and I think it's probably important to say that although the warming of the temperature increases the amount of melt, that increase in melt itself can help to drive the carving of icebergs. That water trickles down and it helps the glaciers to speed up, and some of the cracks in the ice start to get wider because there's water pouring in there. And then at the same time, we've got a warming ocean as well, and that ocean water is coming and undermining these glaciers underneath as they come down and meet the sea. So it's really a lot of different processes coming together and pushing the ice sheet in one particular direction.
I'm going to shoot down to Antarctica now to respond to your questions. Thanks for sending those in. A question from Patrick Madser, who is asking whether we've passed the point of no return on major Antarctic glaciers such as Pine Island and Thwaites. I think, David, that you probably have an answer to that one. Are we in a process now that's irreversible, point of no return, and is Thwaites basically just going to break off and suddenly increase sea level?
The honest answer is we just don't know. We know in its system, and certainly in the Antarctic ice sheet, there is a tipping point that we would expect runaway collapse of the ice sheet to occur. But how close we are, or indeed whether we've exceeded that tipping point, really is not known at present. And we really only time will tell. The same is true of all the other points in the Earth system. They're very straightforward to identify that these tipping points are there, but identifying with a degree of precisely when we've stepped past the point of no return is an extremely difficult scientific task to undertake. So I think the short answer is that the tipping point, time will tell whether we've overstepped the mark.
I suppose one of the problems is, I'm getting, you're breaking up a bit, but I'm getting what you're saying. I guess one of the problems is we don't have another Earth we can go and have a play around with and check things out and change different parameters and settings on, right? Or Anders, do you have one tucked away in the computer somewhere that you can do that with?
No, unfortunately, the computer isn't a perfect representation of reality, but it represents what David just said, and which was which is known already for more than 40 years, that there's a tipping point in so-called marine ice sheets, meaning in ice sheets that are grounded below sea level on land, on the sea floor that's below sea level. And we have this in West Antarctica and parts of East Antarctica. And in 2014, there was a series of studies saying that the West Antarctic ice sheet has now been destabilized in Amundsen Sea sector. Whether this really turns out to be the case, we need to continue the research, and there have been more. There's been more work on it, but this is hanging in mid-air at the moment. It seems that we know that there has been melting in the Amundsen Sea sector. We know that the grounding line, that's the line and where the ice begins to float, right? When it's grounded on land, and then it's flowing into the ocean, and then it becomes thinner and begins to get afloat. We know that this grounding line has shifted inland, and the theory says that once it passes the hill, the top of the hill of the bedrock hill, it'll fall down, tumble down the hill inland, this grounding line, and that is just a metaphor. What it means is that the ice sheet is pushing itself out into the ocean under its own weight, right? And that this is not stoppable anymore. Now, whether it's unstoppable or not is really a matter of further research. But at the moment, there is evidence that this has occurred, but it's not conclusive yet. So if that occurs, then we get 3.5 meters of sea level rise only from this part of the world itself. And then people sometimes say, oh, well, then we don't have to stop global warming because the mess has already been caused. That's obviously nonsense, because there's much more risk all around the planet, and also in Antarctica. There's a part of East Antarctica which can be destabilized similarly. So minimizing the risk means reducing carbon emissions.
We will come back to the carbon emissions questions, because we're getting questions on that one. But I just want you to talk through the scenario of how quickly that happens. So if Thwaites Glacier suddenly, let's say over the course of a year or two, just basically collapses slowly, if that were to happen, I think the data I had was that sea level rise goes up 60 centimeters. Would it go up 60 centimeters in the course of 2 years or a year or whatever? Would it happen really quickly, I suppose, is my question?
No, we're not expecting a wave that'll kill us all. That's not what it is. Sea level rise is a long-term problem. It's something that we set in motion now and will have to live with for centuries to come. That doesn't mean it doesn't matter for the current generation or the next generation. It matters for all of us because it makes coastal protection terribly expensive, right? And it also threatens lives if you don't protect against sea level rise, right? But the big issue with sea level rise is that we set it in motion now, and that it'll continue for long term into the future.
It is worrying, and I suppose we should try to understand what's going on there, because as David was saying, the question is we don't really quite understand it. What are the ways that you can try to understand it better? Obviously you can do computer models and things, but what can you do in Antarctica to try and observe it and understand what's happening there better?
The key thing is really trying to connect the models that we use for projection with the data that we can gather on the ground and from satellite data. And putting all those things together provides us a way of actually testing ours over what's happening at the present. And that gives us confidence for making those projections go, as Anders said, tens of years into the future, perhaps hundreds of years into the future. Moving ice out of the Thwaites Glacier, hundreds of kilometers of ice out of the Thwaites Glacier is definitely going to take some time. And so when we're talking about the full 60 centimeters that Thwaites might cost, that may well be years. But what we do need to understand is just how much sea level rise would actually affect our lives. And when we add up all those contributions to sea level rise, the thermal expansion of the oceans, the melting of mountain glaciers around the world, and then Greenland and Antarctica, they will contribute probably 50 centimeters, more than 50 centimeters of sea level rise over the next century. And that will actually have a big impact on the coastal cities, the coastal ecosystems around the world, where a big storm comes, perhaps every 100 years. And when that big storm comes and it's another 50 centimeters higher and goes even further inland and does that much more damage, even these apparently small rises in sea level will have a huge impact on people's lives and livelihoods around the world. So I think having the precision, it's not just about the big sea level rise, it's actually understanding when we'll get it and how much we'll get, even if it actually sounds like not that much in terms of the sea level going up the beach. It will have an impact on our lives.
Is it already having an impact on our lives? Because I believe sea levels have risen. They did rise over the course of my lifetime, and in the last 100 years or so, they have gone up. Has that already caused a problem? How much kind of rise have we already had?
Last century,
we definitely have sea level rise, and one of the ways it's impacting us is through the money that we're having to put into sea defenses around the world. If you look at the cities around the world that are really prone to coastal flooding, we could look at London and Rotterdam and St. Petersburg and Shanghai. Then all of those cities are putting into place protective measures that cost an enormous amount of money. That's in the rich parts of the world. In the poorer parts of the world, where people don't have the option to build big barriers and dams, they're moving inland because they're finding that the floods that used to come perhaps every generation are now coming every few years and are actually disrupting their lives and their activities. And then, of course, there's the ecosystems. Some ecosystems can cope with some rates of sea level rise, but with areas like mangrove swamps that simply can't keep up with sea level rise and are becoming drowned essentially by it. So I think around the world we see examples in all three of those systems of where current rates of sea level 3 millimeters per year as we're measuring it is actually already having an impact. So when we project into the future and see tens of centimeters, perhaps more than half a meter by 2100, those are going to have big effects.
Anders, can I bring you in on that one as well?
Yes, we've seen about 20 centimeters of sea level rise in the last century, and now just recent satellite pictures, satellite measurements and observational data altogether shows that it's now 5 centimeters every decade, which is a dramatic acceleration actually of sea level rise, which really fits to the big picture of thermal expansion of the ocean increasing, mountain glaciers getting lost all around the planet, and then Greenland and Antarctic are contributing more and more to global sea level rise. So we have to expect that on a warmer planet there is more, there's less ice, which tells you that there will be a higher sea level, but we also observe this now.
I'm going to go back to some of the questions which we're getting, and which I think I'm going to need to bring Ruth in on. Well, whoever fancies having a go at them. They're fascinating questions. Angela Faye's asking how much has the thawing permafrost draining meltwater from the Siberian rivers into the Arctic Ocean prevented the formation of sea ice? Is basically the water in the Arctic Ocean along that Siberian coast getting warmer because you're getting more water coming out of Siberia because you're melting the permafrost?
That's actually a really interesting question. And the answer is no, because fresh water, which we get from the rivers from the Siberian areas, that freezes at a much higher temperature than salt water. So actually what we see in sort of climate simulations is where these rivers come out into the Arctic Ocean, that's some of the last remaining sea ice when we go to these higher temperature scenarios, just because that water is so fresh and it actually is easier to freeze than seawater.
How utterly fascinating. See, this is why I love my job. That was so interesting. Well, so yeah, you could end up having this kind of crust of this fresh water.
Yeah, and so one of the important things that we are concerned about in the Arctic Ocean is what we call the stratification of the Arctic Ocean. So at the moment you have this kind of cold cap, which is cold because in the winter it's dark and it doesn't get heated up by the sun. And then underneath you actually have warmer, saltier Atlantic water, which is much warmer and would be easier would actually give out a lot more energy into the Arctic. And so one of the reasons that people are concerned about the loss of sea ice there is that if that loss of sea ice leads to a breakdown of this cold layer on the surface of the Arctic, then you could actually get a lot more energy coming into the Arctic and preventing and speeding up the decline of any sea ice that's remaining. So it's actually a really complicated system to understand. You have to understand not only the atmosphere, but also the ocean underneath.
There's interesting things going on in the Antarctic as well related to this, and in fact warmer salt water from the oceans coming in underneath some of the the tongues of the glaciers, right, as they go out into the sea, and that's a phenomenon which British Antarctic Survey demonstrated, I think, recently. Could you talk to us a bit about that, because that's really interesting too?
Certainly reported. Yes, we've reported that particular effect of melting of the ice from its underside. But many other researchers have seen that around the Antarctic as well. And we know now that there is only a small corner of the Antarctic where atmospheric warming of the air, is having an effect on the ice. The larger part of the signal is the ocean impact on the ice. The circulation around in a few places brings warm water that has its origins in the tropical regions up onto the Antarctic continental shelf. And as that water comes into contact with the ice, that's really the strongest impetus to melting that ice sees. And so the areas that we've seen, Anders has mentioned some, the Thwaites Glacier that sits in the Amundsen Sea, and a few glaciers that surround it, and then a couple of locations in East Antarctica. In each case, it's the oceans that are having the impact. That adds to the challenge of making projections, because what we're doing in dark side affects atmospheric weather directly. And then it's that atmospheric weather that has the effect on the ocean circulation. And then the ocean circulation melts the ice. So the multiple steps in that chain make the prediction of how things are going to change in future that much harder. But
another question here. Sorry, David, you're breaking up a little bit there.
There is an ocean influence.
Sorry, I'm just jumping in there. Sorry, because it's cutting a little bit with your connection, but it's okay. It's also really interesting. Seems very different kinds of processes going on in Antarctica. Question from Everman Jack: has the increasing output of methane and methane hydrate from the East Siberian Arctic shelf been factored into climate models? Does anybody have an answer to that one?
No, it hasn't. Sorry. Ruth, go ahead.
It has in some models, but it is a process that is not as well studied as perhaps one would like it to be. But we have actually run our own simulations here at DMI where we have tried to force this kind of extra methane on the coastal shelf from Siberia. It turns out to be quite hard to get it to destabilize maybe as quickly as some sort of doomsday scenarios suggest. So there's not been as much research as one might hope. But maybe you have a more...
Would the thinking be that it would be a localized effect? Is that what you're talking about?
No, it's not a localized effect, right? If you put greenhouse gases into the atmosphere, they spread around quite quickly and change the climate all around the globe. No, but what I meant is that the standard climate models, which are being used in the coupled model comparison projects and then are used in the Intergovernmental Panel on Climate Change, those typically prescribe different scenarios of carbon dioxide concentration in the atmosphere, and these additional greenhouse gas emissions coming from the from permafrost thawing or methane hydrates are generally not incorporated to the full extent in these. They come, on top of the warming scenarios that we are putting out there.
Is that because we're just not measuring it properly at the moment? We're not able to get there. We don't have the devices to measure the methane.
No, there's a huge uncertainty there, right, Ruth? I don't know, or David, perhaps you know more about this, but there's huge uncertainties in the observations, but there's also process challenges there, and I think it's also a structural thing in informing the public. There are different steps. One is to say, if I put this amount of greenhouse gases in the atmosphere, how much will the atmosphere respond? How much will the ocean respond? How much will the ice respond due to the warming? And then the second step is to incorporate the feedback through the carbon cycle, which would include not only the methane coming from the permafrost or the methane hydrates, but also obviously and much more prominently the biology and the physics of the ocean that is also taking up or releasing carbon dioxide and methane into the atmosphere. So this is that's a feedback loop that is studied intensely, but it's generally first it's separated from the climate problem and then it's put into the climate problem again. So we know something about it, but it's generally not in these projections.
Enormously complex business. I've just had a question from Mireia Ginesta Fernandez, who's asking, how will the Arctic sea ice loss impact the cyclones in the North Atlantic? So the cyclones, I mean storms, I guess, and hurricanes and things that you might get in Europe. Does the lack of Arctic sea ice change that more, or are they stronger, are they weaker?
There's some evidence that when you get a loss of sea ice in the Arctic, you change the North Atlantic Oscillation, which is this kind of seesaw climate pattern we see, which is really important, especially in Northern Europe. It really determines if we're going to have a wet, miserable grey winter or a cold one. And so this pattern is a pattern of high pressure over the Azores and low pressure over Iceland. And that as the Earth gets warmer and you see Arctic sea ice retreating, you can see that kind of seesaw pattern starts to change. It starts to change its position and it starts to change its strength. But it's not quite clear if that is reflecting what's going on with the Arctic sea ice or if it's just a general response to warming that's going on in the world as a result of climate change. So it could be that this pattern is changing, and then that will have an impact on the track of cyclones across the North Atlantic. So there is an effect, but it's not clear that it's the sea ice that's causing it. It could be just these two are actually responding to the same kind of warming signal.
Another question, which sounds a bit of a doomsday one, but I think it's one which is sort of vaguely on a lot of people's minds, which we've had from Rezayari on Instagram. Thank you for that. Basically asking, will all of this lead to the extinction of the human race? Will it? Will sea level rise and all of this melt eventually basically be incredibly catastrophically bad for humans? Anders?
Well, each of us has an opinion on that, I guess. But it's like let's say I can say that none of us can know this for sure. What I can say is that there is not going to be a runaway greenhouse effect on Earth. That is sometimes out in the public sphere, and that's the idea that a warming that we cause as humans will cause a spiral of further and further warming, which is uncontrollable and will just lead to a very hot climate where humans can't live anymore. This is not going to happen. I think I can say that with some certainty. So I think the challenge of the climate change is really the perturbation of our societies and the conflicts that arise from there. It's not about one big wave of any kind, oceanic wave, sea level rise wave, or any kind of other kind that will simply extinguish us. That's not what it's about. It's about a fireworks of perturbations coming from all directions onto our society, inducing migration, inducing conflict, and thereby potentially tumbling our societies, our democratic societies, or also the non-democratic ones. And that's what we have to be afraid about with respect to climate change.
David, can I bring you in on that? Sorry, you're on a different connection now.
Yeah, I am. I hope it's better. I think that's an excellent question. My feeling is the same as Anders, that this is not something, no matter how hard we're trying to exterminate our own species, actually we won't manage it. The changes that we're looking forward to are going to affect every part of our society, every part of our economic system. But it's perhaps interesting just to think of the changes that we've gone through within the last year with the COVID-19 pandemic. And if we'd imagined a year ago, I think what would have been the response of asking entire nations to stay in their houses for periods of 4 to 6 months at a time, we would have imagined that actually that was pretty unlikely to have stuck, for that request to have stuck, and for pretty unlikely that people would be prepared to change their lifestyles sufficiently to protect themselves. I'm actually take heart from the fact that so many nations have responded so well to the COVID pandemic, and that people really do understand the need to take action. And I hope we can translate some of that energy and positive energy into a response to climate change, changing the way that we interact with our planet and how we consume our planet's resources in the future. I don't think we're going to exterminate ourselves, but I think there's going to be some big changes ahead that we have to accept.
Ruth.
Yeah, I agree very much. I think it's worth pointing out that the effects of climate change, extreme weather, sea level rise, they will have a greater impact on already marginalized communities. So the impacts are not going to be evenly spread out. And so we have to really think about how existing inequalities in societies are maybe going to be affected and maybe magnified as a result of these kind of extreme events. And in that sense, I think COVID is actually quite a good example of that, because that's clearly having an effect very different in different communities. And so I think the US military call it a threat multiplier. And I think that's very true, a very good way of thinking of climate change. It multiplies lots of other threats as well as having a sort of physical impact.
Yes, and if I may add, we're talking about the extinction of the human race, and we all say that this is not going to happen, but that doesn't mean that climate change isn't really doesn't have the potential for disaster. There's a lot of disaster already happening at the moment, but the potential catastrophes that are on a path on which we don't abate climate change are tremendous, and that needs to be pointed out. There is something between extinction and nothing happens, and the whole spectrum of what you can imagine between these two things is what we can imagine under climate change, and we should avoid.
And it's basically all about reducing emissions as soon as we can, getting into a situation where we're controlling our output of CO2 into the atmosphere. That is the way you can fix it, right? There isn't another idea that's hiding somewhere that nobody talks about. That's what we have to do.
Completely.
Perfect. I'm gonna wrap it up there. Thank you, everybody, for joining us, and thank you for your questions, everybody online. It's been fascinating to see how much engagement there's been in this topic. You can read and learn a bit more about climate change going to euronews.com/climate now. And I would like to thank our guests, Ruth Mottram, climate scientist at the Danish Meteorological Institute, Professor David Vaughan, Director of Science at the British Antarctic Survey, and Professor Anders Levermann from the Potsdam Institute for Climate Impact Research. It's been brilliant having you here on Euronews YouTube channel. And please let us know what you would like to have discussions about in the future, because we're going to have another discussion next month, and we'll be coming back answering more of your questions. Thanks very much for watching.